hydrogen into the tanks of the upper stage. And to keep them liquid, as you said, we must have temperature, very, very low temperature. We are talking minus 253 degrees for liquid hydrogen and minus 180 for liquid oxygen. So you can see some smokes on the screen, and that's due to this reason. And we actually top up to almost the last instant, and at liftoff you will see these yellow arms being detached and retracting away from the launcher to clear the path.
Good view of them there, isn't it?
Very nice
going
shot.
From the gantry to the rocket. Very, very
And we
cool
can see also the umbilical links in between the mast on the right and the launcher on the left, which are, as a baby with his mother, they are feeding the launcher with electrical power, air conditioning, etc. And they will disconnect automatically at
launch. And we've seen, just briefly mention the Vulcan engine, we've seen that earlier, and that is going to switch on.
DDO. Attention pour moins 1 minute.
7 seconds before launch.
Top, agissez moins 1 minute.
We are 1 minute to launch. Our very best wishes now to all the teams who have been working so hard for today. Good luck, everyone.
Yeah, have a good ride, Ariane 6 and Sentinel-1D.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage de ESR et décollage. La propulsion est nominale. Début de la manœuvre en roulis. Le pilotage calme, la trajectoire est nominale, les paramètres à bord sont nominaux.
Copernicus Sentinel-1D has started its journey on board Europe's newest rocket, Ariane 6, hauling itself against the gravity of our planet.
Amazing views, wow.
Sensational images from our onboard cameras.
Wow.
Right now, we are burning 3 engines. Our range operations manager is telling us that everything is going normally. We can hear the rumble.
I can feel the wall of the room shaking.
We can indeed, as it flies over.
Flying over. Wow.
You can see there the 2 boosters are doing all the work right now, Samuel.
Yeah, almost all the work. 85% of the effort is indeed brought by the boosters. It's a giant piece of power because they are filled with 142 tons of propellant each, and we are burning them in a bit more than 2 minutes. So we're actually burning around 2 tons per second here. That's really massive.
That's a lot of fuel, and we got a great shot of them there, those 2 dots. He's telling us that everything's going normally.
And we should potentially see the booster separation that should arrive soon. And you can see even the 3rd spot of the Vulcan engine at the center of the 2 nozzle of the 2 boosters.
That's right, the white dot is the Vulcan engine, and there we can see the 2 boosters now being jettisoned.
See that 2 boosters, 1 up, 1 left down, moving away from the central stage.
And they detach from the rocket thanks to a pyrotechnic device, which is made by a company called Pyro Alliance, who are real experts in this.
Indeed, they are providing pyrotechnic systems, and they are used to separate the rocket, elements, as we see on the screen, like boosters. We used them for the previous step. We'll use them again in the next steps of our launch, as you'll see. Nice, super nice videos here from the onboard cameras where you can see the boosters moving away.
We get those images for technical reasons from the onboard cameras, just a few seconds delay. So there we can see those two boosters having fallen away, and the range operations manager telling us everything's going normally and according to plan. Got our satellite tucked away inside the top of our rocket, still being protected at this point by the fairing.
Yes, indeed. And the fairing has several jobs. First, of course, is to protect the satellite on ground from the dust and humidity of French Guiana.
And we've just had confirmation there that we've actually separated our fairing.
And this is because when we cross the atmosphere, it protects the satellite from the friction with the air that generates heat and vibrations. And now, as we are over, we've passed the atmosphere, we can jettison in.
And you can see there,
that's nice.
It's actually moving, isn't it? It's called the breathing mode.
Exactly. This is due to the effort of separation system, which kind of deforms the fairing, and it generates an oscillation mode. We call it breathing mode, indeed.
Indeed, and it's all part of the plan, flexing as it falls. He's telling us the propulsion is normal. Everything's going well. Everything's going according to plan right now. And our camera looking down our rocket. On the top right-hand side of your screen, that's the trajectory. The green line is the planned trajectory, and the white cross is the actual position of our rocket. And you can see there our altitude. At the moment, we're 146 kilometers above our planet and climbing. The distance is our distance from the planet if you were to draw a straight line, and our speed on the right-hand side. Vitesse is the French word for that. So we're burning the big tank of fuel on the main stage, Samuel.
Yeah, it doesn't seem to be so big seen from onboard cameras, but indeed it's quite big. Its height is 32 meters, and its weight is 23 tons. It's not so big when you compare the mass of it with what it's containing. It carries 154 tons of cryogenic propellant, so it's quite efficient in terms of mass versus propellant inside.
And we can see on the bottom right of your screen, that's the 3D animation or the CGI images. It's an animation of what's happening in space, so it gives us an idea of what it looks like up there, the Sentinel-1D satellite attached there to the top of our rocket. Now we're getting closer now, about 2 minutes away from the next big event. You can see the events on the left-hand side of your screen. The next big event will be the separation of that big tank of fuel, the main stage.
Yeah, indeed. The guidance algorithm inside the onboard computer will detect that we have reached the right orbit for this instant, and then it will send the shutdown command to the Vulcan engine and then jettison the main stage.
And separating each section of the rocket may look simple when you see it on the animation, but actually there's an awful lot happening up there, isn't there?
Yeah, it's
a very critical moment.
It's clever stuff here, yeah, indeed, because when you separate the stage, it must be quick enough, but it needs also to be very well mastered, because you don't want to have any collision. And here, you remember, here to do that, we use pyrotechnics, again, as we mentioned, Pyro Alliance. Earlier, we are using their technology again for this type of stage separation. They have developed a mild detonating cord, which is a detonating component. It's inserted into a tube which deforms and then cleanly breaks the part that relates the upper and the main stage. And then, once cut, we gently push the lower stage with a set of springs, and this to ensure sufficient clearance in a short amount of time, and because then we need to fire the upper stage engine, so we want to be sure the lower stage is separated and sufficiently far away.
It needs to be quick and it needs to be clean.
Indeed.
And Pyro Alliance has been supplying these mild detonating cords for many decades, and they've actually delivered a total of more than 100 kilometers of cords.
Which is huge when you realize that for one launcher we're talking meters not kilometers.
Extinction Vulcain.
We have confirmation there that we've switched off the engine
Séparation LEPM.
and jettisoned the big tank there, the main stage.
Allumage du moteur Vinci.
And we have confirmation that we have now switched on
And look
the...
on the picture, I think the video will see the main stage separation shortly. Yeah, here it comes. Nice view. This is seen from the lower part
nominal.
of the Vinci. Nice.
Fantastic image there of it being jettisoned.
And see, jettison and then tilted slightly so that the Vinci, when ignited, doesn't throw a propellant to the,
Fin du dogleg après séparation. Pilotage calme.
to the rear bulkhead.
So we're launching a satellite to monitor our planet today, but satellites do lots of other things.
Yes, indeed, they also help us to any kind of things, like connect with each other, like navigate our planet, like protecting people and animals, managing disasters, helping the armed force in combat.
Pilotage calme. Propulsion nominale.
And when you think about telescopes and space probes, they help us understand our universe.
Premier allumage de l'APU.
Indeed, but first of all, you've got to get them into space, and that's where Arianespace comes in, because they are Europe's leading provider of rocket launches. And I think it's fair to say that they don't just launch satellites, they launch people's ambitions.